Chapter 1 Review, Key Terms and Equations. A. Key terms. 1. Absolute temperature scale. Scale, such as Kelvin, with a 0 point that is absolute zero. 2. Absolute zero. Temperature at which the average kinetic energy of molecules is zero. 3. Calorie, cal. Energy needed to change the temperature of 1.00 gram of water by 1.00 degrees Celsius. 4. Calorimeter. Container that prevents heat transfer in or out. 5. Calorimetry. Study of heat transfer inside a container impervious to heat. 6. Celsius scale. Temperature scale in which the freezing point of water is 0 degrees Celsius and the boiling point of water is 100 degrees Celsius. 7. Coefficient of linear expansion, alpha. Material property that gives the change in length, per unit length, per 1 degree Celsius change in temperature. A constant used in the calculation of linear expansion. The coefficient of linear expansion depends to some degree on the temperature of the material. 8. Coefficient of volume expansion, beta. Similar to alpha but gives the change in volume, per unit volume, per 1 degree Celsius change in temperature. 9. Conduction. Heat transfer through stationary matter by physical contact. 10. Convection. Heat transfer by the macroscopic movement of fluid. 11. Critical point. For a given substance, the combination of temperature and pressure above which the liquid and gas phases are indistinguishable. 12. Critical pressure. Pressure at the critical point. 13. Critical temperature. Temperature at the critical point. 14. Degrees Celsius, degrees Celsius. Unit on the Celsius temperature scale. 15. Degree Fahrenheit, degree Fahrenheit. Unit on the Fahrenheit temperature scale. 16. Emissivity. Measure of how well an object radiates. 17. Fahrenheit scale. Temperature scale in which the freezing point of water is 32 degree Fahrenheit and the boiling point of water is 212 degree Fahrenheit. 18. Greenhouse effect. Warming of the Earth that is due to gases such as carbon dioxide and methane that absorb infrared radiation from Earth's surface and re-radiate it in all directions, thus sending some of it back toward Earth. 19. Heat. Energy transferred solely due to a temperature difference. 20. Heat of fusion. Energy per unit mass required to change a substance from the solid phase to the liquid phase, or released when the substance changes from liquid to solid. 21. Heat of sublimation. Energy per unit mass required to change a substance from the solid phase to the vapor phase. 22. Heat of vaporization. Energy per unit mass required to change a substance from the liquid phase to the vapor phase. 23. Heat transfer. Movement of energy from one place or material to another as a result of a difference in temperature. 24. Kelvin scale, K. Temperature scale in which 0 K is the lowest possible temperature, representing absolute zero. 25. Kilocalorie, kcal. Energy needed to change the temperature of 1.00 kilogram of water between 14.5 degrees Celsius and 15.5 degrees Celsius. 26. Latent heat coefficient. General term for the heats of fusion, vaporization, and sublimation. 27. Mechanical equivalent of heat. Work needed to produce the same effects as heat transfer. 28. Net rate of heat transfer by radiation. P net equals sigma E A open parenthesis T2 to the power of 4 minus T1 to the power of 4 closed parenthesis. 29. Phase diagram. Graph of pressure versus temperature of a particular substance, showing at which pressures and temperatures the phases of the substance occur. 30. Radiation. Energy transferred by electromagnetic waves directly as a result of a temperature difference. 31. Rate of conductive. Heat transfer rate of heat transfer from one material to another. 32. Specific heat. Amount of heat necessary to change the temperature of 1.00 kg of a substance by 1.00 degrees Celsius, also called specific heat capacity. 33. Stefan-Boltzmann law of radiation. P equals sigma A E T to the power of 4, where sigma equals 5.67 multiplied by 10 to the power of negative 8 joules over second dot meter squared dot K to the power of 4. Is the Stefan-Boltzmann constant. A is the surface area of the object, T is the absolute temperature, and E is the emissivity. 34. Sublimation phase. Change from solid to gas. 35. Temperature. Quantity measured by a thermometer, which reflects the mechanical energy of molecules in a system. 36. Thermal conductivity. Property of a material describing its ability to conduct heat. 37. Thermal equilibrium. Condition in which heat no longer flows between two objects that are in contact. The two objects have the same temperature. 38. Thermal expansion. Change in size or volume of an object with change in temperature. 39. Thermal stress. Stress caused by thermal expansion or contraction. 40. Triple point. Pressure and temperature at which a substance exists in equilibrium as a solid, liquid, and gas. 41. Vapor. Gas at a temperature below the boiling temperature. 42. Vapor pressure. Pressure at which a gas coexists with its solid or liquid phase. 43. Zeroth law of thermodynamics. Law that states that if two objects are in thermal equilibrium, and a third object is in thermal equilibrium with one of those objects, it is also in thermal equilibrium with the other object. B. Key equations. 1. Linear thermal expansion. Delta L equals alpha L delta T. 2. Thermal expansion in two dimensions. Delta A equals 2 alpha A delta T. 3. Thermal expansion in three dimensions. Delta 5 equals beta V delta T. 4. Heat transfer. Q equals M C delta T. 5. Transfer of heat in a calorimeter. Q cold plus Q hot equals 0. 6. Heat due to phase change, melting and freezing. Q equals M LF. 7. Heat due to phase change, evaporation and condensation. Q equals M LV. 8. Rate of conductive heat transfer. P equals K A open parenthesis TH minus TC closed parenthesis divided by D. 9. Net rate of heat transfer by radiation. P net equals sigma E A open parenthesis T2 to the power of 4 minus T1 to the power of 4 closed parenthesis.